Come back. So now we start working on web work problems, section 2.7. So notice there are 8 problems. Let's start from the first one. A particle moves along a straight line with the equation of motion to be s equals t cubed minus 4t squared. Find the value of t other than 0 at which the acceleration is equal to 0. All right, you are given position t cubed minus 4t squared. Velocity is derivative of position. Okay, velocity is derivative of position. So take the derivative with respect to t, of course, 3t squared minus 8t. Acceleration is derivative of velocity with respect to time. So derivative of this is 6t minus 8. You want acceleration to be 0. So acceleration is 0 means 60 minus 8 is 0. Solve for time. Move the 8 over, divide by 6. 8 over 6, which reduces to 4 over 3. Next, you are given a particular position, a particle moving according to position function. Find the velocity. What is the velocity after 3 seconds? When is the particle at rest? Find the total distance traveled in first 8 seconds. All right. So here is your position. A part is find the velocity. Velocity is simply derivative of position. So 3t squared minus 18t plus 15. 3t squared minus 18t plus 15. All right, that's the velocity function. Question is, what is the velocity when t is 3 seconds? Substitute t equals 3. You get 3 squared minus 18 times 3 plus 15. All right, so that is simply that. So 9 times 3, 27 minus 54 is negative 27 plus 15. That's a negative 12. Okay, you could simply write this expression here, but I have calculated it. Now, C part is, when is the particle at rest? The particle is at rest when velocity is 0. So that is your velocity. That has to be 0. So you need to factor it. Common factor 3. Factor this. You get t equals 1 and t equals 5. All right. So the smaller one first. So 1 first and then 5 next. Now total distance. Okay. So total distance is given like this. Y, you're starting from total distance covered during the first 8 seconds, means you're starting at 0. So don't forget absolute value. Why absolute value? Because you could be moving back. So you want to make sure the total distance is the absolute value s of 1 minus s of 0. Where did 1 come from? This one. All right. So for the first second, time t equals 0, time t equals 1. Find the difference, take the absolute value, plus S5 minus S1. Where did this 5 come from? Again here. All right. So the difference, so the point is, at some point you're moving forward, then you're possibly moving backward, then you're moving forward, and so on and so forth. So the times when you turn around, those times are when velocity is 0. And so you're first identifying where the velocity is 0, and those are your cut points, right? S5 minus S1, and the final 8 seconds, S8 minus S5, don't forget absolute. So this is the total distance. Now for this total distance, I'm going to have to use my function of s. You see? So what's going to happen here is s at 1, plug in 1, and then s at 0, and so on and so forth. So what we are going to do for this is, I have simply written down the value here. All right. So let's open our calculator. Okay. So that's where I'm getting those numbers from. All right. So s at 1, what do? I plug in 1 power 3 minus 9 times 1 power 2 plus 15 times 1 plus 9. That gets me 16. So 16 minus, so I need to bring in all possible numbers. So that was s of 1. When I plug in 0 for t, I get 9. That is s of 0. All right, absolute value plus. Now I want s of 5 minus s of 1. Remember, s of 1 was already 16. So now we need 5. Okay. That's negative 16. So absolute value negative 16 minus 16. After s of 5, I need s of 8. That gets me 65. So that's the last one. S of 8 minus S of 5. Remember, S of 5 was negative 16, so that becomes a plus instead inside. So all of this. So the first pair, you see, I have absolute value S1 minus S0. Because S1 is bigger than S0, I didn't write absolute value, but to be safe, you might want to write absolute value there. So that gets me S1 minus S0 plus S5 minus S1 plus S8 minus S5. Okay, so I did not calculate it, I just wrote on the expression and we are done. All right, so next video will cover problem 3.